My name is Ruud Molenbroek. I had a short introduction movie as well, but in the interest of time, let's skip it. I'm a project manager at BTG Bioliquids. Last project I was responsible for was the construction of a pyrolysis plant in Finland. Here today talking mostly on advanced biofuels. So this is a big overview of all the options with our product, pyrolysis oil. But to borrow a line from Professor Kramer, I can easily simplify this for you. Right now, many different types of biomass residues can be used in our process, fast pyrolysis, to convert it into bio-oil. Right now, we've combustion and heat and power, that has been commercialized. We're doing it every day now. Today, mostly we'll be talking about the advanced biofuels routes, mainly the three routes: gasification, Fcc co-feeding, and hydrotreatment. And other options to do with pyrolysis oil include bio-based chemicals, various routes, but we won't be talking about that today. So the technology itself, actually we like to keep it as simple as possible. It's a quick heating and quenching of the biomass using sand, just sand, so no catalyst. Can be done in the field, close to where the biomass is released, next to sawmills, etc. And that converts different types of biomass residues. At the moment it's still woody residues, but can also be corn stover, straw, etc. into fast pyrolysis bio-oil. And byproducts are heat and steam. So of every ton of biomass going in, about 2/3 is converted directly to the bio-oil, and the rest is gas and biochar, which are inside of our installation, combusted and converted to steam and power, and also used efficiently. The first plant we built was in 2015. It's in 24/7 operation ever since. Empiro in the Netherlands, close to my home, Hengelo. The feedstock is wood residue, two different types. Takes in about 36,000 tons per year and produces 24,000 tons of pyrolysis oil. So that's about 3 truckloads, 80 tons per day, every day. Outputs also steam. You can see the steam line going to our neighbor, which they use to reduce their natural gas consumption, and power. And so this is basically, in the overview, this is the application, pyrolysis oil to heat and power. Now there's more. In 2020, that's my plant actually in Finland. We brought modules to site, stacked them up on top of each other, and did the startup and commissioning. And we actually got, within, I think, August, we got the plant on site. In December, we started production. So it's really rapid from construction to production. And it's been producing ever since. And the second one, we did the same trick again in Sweden, next to, again, a sawmill in 2021. Now let's look at this one in Sweden. So we've got, it started up in September 2021. We do it now with Technip Energies, large EPC provider, lump sum turnkey, so fixed price. You pay us, we deliver a running plant to you. Same size, 24,000 tons. And interestingly, already we're taking the first step to advanced biofuels, because they are going to the refinery with this. They are co-processing it as we speak. Last month they released a statement. They have co-processed the first 2,000 tons in an existing refinery unit, Fcc. And this is fully compliant with the EU Renewable Energy Directive with the Annex 9 Part A, so non-capped, fully renewable streams. How do we do it? Very simply put, the black is an existing refinery. We simply add a line, some tanks, a pump, and we feed in with the existing VGO stream, and that makes that the pyrolysis oil ends up in the products. That's of course very much simplified, but you can do a C14 carbon analysis and you see this ending up in the product. Now, if you want to go really in depth on this, we've put some white papers on our website, and there's actually a publication coming up on the LCA of this whole value chain and the carbon tracking in the refinery. This is the very quick summary of this LCA, life cycle analysis. If you look at regular gasoline and you track all of the energy streams and all of the energy you use during this pyrolysis oil production and also the co-refining, you're looking at a greenhouse gas savings of about 90%, 90. So that's huge. It's a very interesting route. Now, here is where it gets complicated because there's so many options with pyrolysis oil. So this is the first route. This is the Fcc route. Extensive testing has been done in the US, in Europe, and the downside of this is you can only co-feed around 5%, maybe 10%. It's still huge. I mean, one refinery takes about 5-6 pyrolysis plants. If you want to go higher in the co-feeding ratio, 20-30%, you need to upgrade the pyrolysis oil first. This can be done with a proprietary catalyst our parent company has developed, and hydrogen, and that produces something much closer to conventional hydrocarbons, and you can co-feed that. What you could also do, and this is the green route on that chart, is full standalone upgrading. So first you stabilize the pyrolysis oil to something close to hydrocarbons, and then you do hydrotreatment, and you get a hydrotreated pyrolysis oil, which is completely missable. And with that route, we are currently targeting the marine sector through BTG Next. 1/4 route is the gasification route, as SkyEnergy Oscar already mentioned. This is the most likely route to sustainable aviation fuels, where you do simply gasifying of the pyrolysis oil. Benefit being the pyrolysis oil is something homogeneous, you can pump, you can store, and nearly all of the contaminants have been removed, so it's very straightforward to gasify. Now, with all of these routes, our business model is the same. Take the biomass locally within a small radius of this pyrolysis plant. It's a small plant. Bring it together, upgrade it to pyrolysis oil. That makes it easy to transport. It's much more dense. Transport it to a central upgrading location where you benefit of the economy of scale and co-process or process it to biofuels or biochemicals. So, in summary, the bio-oil production step has reached commercial maturity. We've sold 3 plants so far. We're working on more. The advanced biofuels, we're starting to reach commercial maturity. So the FCC unit we've seen, it's being done on an industrial scale since this year with the Preem in Sweden. It has very low capex, so you don't have to invest in a huge pyrolysis or upgrading plant. Short time to market and very quick and very large GHG emission reductions. And so this FCC route, great route, but limited to about 5%. And the other refinery pathways, they're at various stages of maturity. So hydrotreating, hydrocracking, gasification, still being developed, not just by us, but the way we see it, we make the pyrolysis oil. Any party in the world can order oil from us or from our clients, or and do this upgrading themselves. So, thank you for your time.